Hello everyone! Today is a new day, new life, new beginning, and new lesson. Once again, I'm Teacher Angie. Our lesson for today is about inverse variation. Ano nga ba ang inverse variation? If two variables are so related such that as one variable increases, the other variable decreases proportionally. The relationship is called inverse variation, meaning kung yung isang variable ay tumataas, yung isang variable ay bumababa. And vice versa. If ang isang variable ay bumababa, yung isang variable ay tumataas. Next, in inverse variation, y varies inversely as x and y is inversely proportional to x. If there is a non-zero constant k such that y is equal to k over x or k is equal to xy, where k is the constant of variation. Meaning to say, ang k dapat natin ay hindi 0. For example, A, write an equation for the following statements. Example number 1, the number of hours H to complete a certain job varies inversely as the number of people P working on it. So, paano natin ito gagawa ng equation? So, the number of hours, so H tayo is equal to inversely, then K all over P. Therefore, we have H is equal to K over P. Number 2, the altitude of a triangle A with a constant area is inversely proportional to its base B. So, we have A is equal to K over B. Kasi meron tayong A dito for the altitude and for the B base. Next, number 3. Air pressure P varies inversely for its altitude A. So, gaya ng sinabi ko, yung naunang binanggit na variable, yun din ang mauuna nating isulat. Therefore, we have P is equal to K over A. For number 4, the amount of sales S of a constant commission varies inversely as the rate R of a commission. So, S ang naunang binanggit, therefore we have S is equal to K over R. Example, letter B. Find the constant of proportionality. For example, number 1, E is inversely proportional to Z is equal to 4 when E is equal to 6. So, find first the given. Z is equal to 4 and E is equal to 6. And for our equation, E inversely proportional to Z, so we have E is equal to K over Z. Then, for our solution, we will use the equation E is equal to KZ. Then, substitute the given. E is equal to 6 and Z is equal to 4. To isolate K, we're going to multiply both sides by 4. So, 4 times 6 is equal to K over 4 times 4. Now, we're going to cancel 4 and 4. Therefore, we have K is equal to 4 times 6. And 4 times 6 is equal to 24. Therefore, our final answer is K is equal to 24. Number 2, Z is inversely proportional to the sum of X and Y. And the sum of X and Y is 10 when Z is 4. So, what are the given? Z is equal to 4. Y plus X is equal to 10. And for our equation, we have Z is inversely proportional to the sum of X and Y. So we have Z is equal to K all over X plus Y. Then substitute the given. Z is equal to 4 is equal to K. X plus Y is equal to 10. To isolate 10, we're going to multiply both sides by 10. So 10 times 4 is equal to K over 10 times 4. Then cancel 10 and 10. So we have now K is equal to 10 times 4. And 10 times 4 is equal to 40. Number 3, R is inversely proportional to the square of L. And L is equal to 3 when R is equal to 5. So what are the given? R is equal to 5 and L is equal to 3. And for our equation, are inversely proportional to the square of L. So we have R is equal to K all over L squared. Next, for our solution, we're going to use the equation R is equal to K all over L squared. Then substitute the given. For our R, 5, and for our L, 3. So we have here 5 is equal to K all over 3 squared. So we need this square first, 3. Therefore, we have 5 is equal to K all over 9. So to isolate K, we're going to multiply both sides by 9. Therefore, we have 9 times 5 is equal to K over 9 times 9. So cancel now 9 and 9. Therefore, we have K is equal to 9 times 5. And 9 times 5 is equal to 45. Therefore, our K is equal to 45. Number 4, f varies inversely as the cube root of n, and n is equal to 64 when f is equal to 100. So what are the given? F is equal to 100 and n is equal to 64. And for our equation, f varies inversely as the cube root of n. So we have f is equal to k all over cube root of n. Then substitute the given. F is equal to 100 is equal to k all over cube root of n is equal to 64. To extract the cube root, we need first to find the factor of 64 wherein it is a perfect cube root. So we have now 100 is equal to k all over cube root of 4 cube because 4 cube is equal to 64. Next, 100 is equal to, of course, cancel na natin ang cube and then yung cube root. So, pag natanggal na yan, kung ano yung radicand mo, yun na ang matitira. So, we have 4. Therefore, we have now 100 is equal to k all over 4. So, to isolate 4, we need to multiply both sides by 4. Therefore, we have 4 times 100 is equal to k all over 4 times 4. And then, cancel 4 and 4. So, we have now k is equal to 4 times 100, which is 400. Therefore, our final answer is k is equal to 400. Example letter C. Solve each problem. Example number 1. If t varies inversely as the sum of m and n, and t is equal to 30 when m is equal to 2 and n is equal to 5, find t when m is equal to 5 and n is equal to 3. So we're going to write the given first. T1 is equal to 30, M1 is equal to 2, and N1 is equal to 5. And for T sub 2, it is our unknown. M sub 2 is equal to 5, and N sub 2 is equal to 3. Equation, T varies inversely as the sum of M and N. So we have now T is equal to K all over M plus N. And for our constant, K is equal to T times M plus N. Solution, finding for the constant. So we will use the constant equation. K is equal to T times M plus N. Substitute the given. T is equal to 30. M1 is 2. N1 is 5. So we need to add first the number inside the parentheses by using the PEMDAS. So we have now K is equal to 30 times 2 plus 5 is 7. And 30 times 7 is equal to 210. Solving for T sub 2. So we're going to use the equation. T sub 2 is equal to K all over M sub 2 plus N sub 2. Then substitute the given. T2 is equal to, our K is 210. All over M sub 2 is 5 plus N sub 2 is 3. So we're going to perform first the operation inside the parentheses. So we have T sub 2 is equal to 210 all over 5 plus 3 is 8. Then 210 divided by 8 is equal to our T sub 2. Therefore, our final answer is 26.25. Example number 2, if P varies inversely as Q and P is equal to 8 when Q is equal to 2, find P when Q is equal to 4. So find the given first. P sub 1 is 8, Q sub 1 is 2, and P sub 2 is the unknown, and Q sub 2 is equal to 4. Next equation, for our variation, P varies inversely as Q, so we have P is equal to K over Q. And for our constant, K is equal to P times Q. And our solution, solving for K, using the constant equation, K is equal to PQ, substitute the given, K is equal to P is equal to 8, and Q sub 1 is equal to 2. Therefore, 8 times 2 is equal to 16. So K is equal to 16. And solving for our unknown P sub 2, we're going to use the equation for the variation P sub 2 is equal to K all over Q sub 2. So substitute the given. P sub 2 is equal to, or K is 16, divided by Q sub 2 is equal to 4. So 16 divided by 4 is equal to 4. Therefore, our P sub 2 is equal to 4. Example number 3. If y varies inversely as x, and x is equal to 13, when y is equal to 9, what is the value of x if y is equal to 45? First, we need to find the given. So x sub 1 is equal to 13. X sub 2 is our unknown. And for our y sub 1, we have 9, and y sub 2 is equal to 45. And for our equation, for our variation, y varies inversely as x, so we have y is equal to k over x. And for our constant, we have k is equal to x times y. And for our solution, finding for our constant k is equal to xy, then substitute the given. K is equal to, our x is 13 and y1 is equal to 9. So 13 times 9, we have k is equal to 117. And solving for our unknown x sub 2, we have a variation equation y is equal to k all over x. Since we're going to find y sub 2, so we're going to use y sub 2 is equal to k all over x sub 2. Then substitute the given. Y sub 2 is equal to 45 is equal to, our k is 117 all over x sub 2. Then cross product, 45 times x sub 2 is equal to 117. And to isolate x sub 2, we're going to divide both sides by 45. So 45 x sub 2 divided by 45 is equal to 117 all over 45. So cancel now 45 and 45. So we have now x sub 2 is equal to 117 divided by 45, which is 2.6. For example, number 4. If r varies inversely as t and r is equal to 132 when t is equal to 4, find r when t is equal to 32. So let's find the given. R sub 1 is equal to 132. R sub 2 is for our unknown. T sub 1 is 4 and T sub 2 is 32. And for our equation, R varies inversely as T. So we have R is equal to K over T. And for our constant, we have K is equal to RT. And for our solution, finding for K is equal to RT. So substitute, K is equal to, R is 132 times T sub 1 is equal to 4. So 132 times 4, we have 528. So for our K, we have 528. Solving for the unknown R sub 2, we're going to use the variation equation. R sub 2 is equal to K T sub 2. So we're going to use this given. Then substitute, R sub 2 is equal to, our K is 528 divided by T sub 2, which is 32. So 528 divided by 32, we have R sub 2 is equal to 16.5. Example number 5. If y is inversely proportional to the square of x and y is equal to 4 when x is equal to 8, find x when y is equal to 16. First, find the given. X sub 1 is equal to 8. X sub 2 is the unknown. Y sub 1 is equal to 4 and y sub 2 is equal to 16. Next equation. For our variation, y is equal to k all over x squared. And for our constant, k is equal to x sub 1 squared all over y sub 1. And solution, finding for k or constant. So we're going to use the equation k is equal to x squared all over y sub 1. Substitute the given. Our x sub 1 is 8, so 8 squared times y sub 1 is 4. 8 times 8 is equal to 64 times 4. And 64 times 4 is equal to 256. Solving for x sub 2, we're going to use the equation y sub 2 is equal to k all over x sub 2 squared. Then substitute the given. For our y sub 2, we have 16 is equal to k is equal to 256 divided by x squared. Next, multiply 16 times x squared is equal to 256. Then isolate for our variable by dividing both sides by 16. So we have now 16 x squared all over 16 is equal to 256 all over 16. So we can cancel now 16 and 16. Therefore, we have x squared is equal to 256 divided by 16, which is 16. So to extract the square, first we're going to find a perfect factor of 16, which is 4 squared. And then since x squared and 4 squared are perfect root, so we're going to put square root both sides. So cancel now the root and this square. Therefore, we have x now is equal to 4. If s is inversely proportional to square root of t and s is equal to 7 when t is equal to 9, find the value of s when t is equal to 27. First, let's find the given. S1 is 7. S2 is the unknown. And for our t sub 1, we have 9. T sub 2 is 27. Equation S is inversely proportional to square root of t. So we have S is equal to k all over square root of t. And for our constant, k is equal to s square root of t. Then solution, solving for constant k. So we have k is equal to s square root of t. Then substitute the given. K is equal to s is 7 multiplied by the square root of t sub 1, which is 9. Perform first square root of 9, which is k is equal to square root of 3 squared. Then 3 squared is a perfect square root. Cancel the radical sign and the square. Therefore, we have now k is equal to 7 times 3. Then 7 times 3 is equal to 21. So for our k, we have 21. And solving for our unknown s sub 2, we're going to use s sub 2 is equal to k all over square root of t sub 2. Then substitute the given. S sub 2 is equal to, our k is 21 divided by square root of t sub 2, which is 27. Then find the factor of square root of 27, wherein one of the factor is a perfect square. So we have s sub t is equal to 21 all over square root of 9 times 3. And then write 9 in exponential form. S sub t is equal to 21 all over square root of 3 squared times 3. Then we're going to move out the perfect squared. So cancel na ang radical sign and the square. Therefore, we have s sub t is equal to 21 all over 3 At saka yung not perfect square ay nasa loob pa rin ng radical sign. Then next, 21 and 3 are both whole number, wherein 21 and 3 are both divisible by 3. So 21 divided by 3, we have 7 all over square root of 3. And of course, if that denominator is radicals, then we need to rationalize. Therefore, we're going to multiply both numerator and denominator by square root of 3. So we have now 7 all over 3 times square root of 3 all over square root of 3. So 7 times square root of 3 is equal to 7 square root of 3, and square root of 3 times square root of 3 is equal to 9, and the square root of 9 is 3. Therefore, our final answer is 7 square root of 3 all over 3. Example number 7. The law of the lever states that to balance a given person seated on a seesaw, the distance d the other person is from the fulcrum is inversely proportional to that person's weight w. Jen weighs 100 pounds and sits 4 feet from the fulcrum. Jay weighs 80 pounds. How far from the fulcrum must Jay sit to balance the seesaw with Jen? Representation: W, person's weight, and D, distance of the other person from the fulcrum. Given D sub 1 is equal to 4 feet, D sub 2 is the unknown, and for our W sub 1, 100 pounds, and W sub 2, 80 pounds. Next equation, for our variation equation, D is equal to K over W, and for our constant, K is equal to D times W. Solution, finding for K is equal to dW. Then substitute the given. K is equal to, for D, we have 4 feet times W, 100 pounds. So K is equal to 4 times 100, and 4 times 100 is equal to 400. Next, finding for D sub 2. We have the equation D sub 2 is equal to K all over W sub 2. We're going to use this given. Then substitute the given. D sub 2 now is equal to, our K is 400 all over W sub 2 is 80. And 400 divided by 80, we have 5. Therefore, our D sub 2 is equal to 5. Therefore, the distance of J from the fulcrum to balance the seesaw with Jen is 5 feet. Example number 8. The number of hours T required to finish a certain job varies inversely as the number of persons N on the job. If 16 persons required 16 hours to finish the job, how long would it take 64 persons to finish the job? Representation: T, number of hours required to finish a certain job, and N, number of persons on the job. For our given, T sub 1 is equal to 18 and T sub 2 is the unknown. And for our N sub 1, 16, N sub 2 is 64. Equation for our variation, it says here the number of hours T required to finish a certain job varies inversely as the number of persons N on the job. So we have T is equal to K all over N. And for our constant, we have K is equal to Tn. Solution, solving for K, we have K is equal to T sub 1 times N sub 1. Then substitute the given. T sub 1 is 18 and N sub 1 is 16. Then multiplies 18 times 16, we have 288. So therefore, K is equal to 288. Solving for T sub 2. So we have T sub 2 is equal to K all over N sub 2. Then substitute the given. T sub 2 is equal to, K is equal to 288 divided by N sub 2 is equal to 64. 288 divided by 64 is equal to 4.5. Therefore, it takes 4.5 hours for 64 persons to finish the job. That's all for today. I hope you learned something from this video. Thanks for watching. Please do watch, like, share, and subscribe. Keep safe. God bless us all. Bye.